This assessment right here, and what I did was I reworked the problem where pretty much I basically show how I understand what's actually going on now. So what I did was first I found out right here, what is the magnitude of the acceleration? This is basically what the question is asking. This is a description of an explanation of the problem. A box with 2.5 kilograms sitting on a roof with a 25 degrees incline above the horizontal, where the kinetic coefficient, which means it will be moving, the kinetic coefficient of kinetic friction between the box and the roof is 0.2, and the roof is 2.5 meters above the ground. This is pretty much irrelevant in this case right now, so I'm going to just exclude that out the whole problem. So the first thing I chose was, first thing I decided to do was to show my free body diagram how this normal force was on the y-axis and how the force friction kinetic is on my x-axis. So it pretty much shows exactly how it is supposed to be in a free body diagram. And my mass times gravity, which is my weight, of course, sits at the bottom. And due to the tilt to show my axis and everything, all right, the angle is going to be over here. 25-degree angle, x-axis, since it's parallel. Well, this is the x side, since it's going to be parallel to the x-axis. And this is the y, sits on the y-axis. And this being the hypotenuse. So to find my x is going to be, of course, sine, opposite over hypotenuse, and cosine for my y, adjacent over hypotenuse. So what also do I know? Well, I know that since I have a friction, force friction, kinetic energy is going to be mu k times normal force. So just sit there here for right now. So my f of x being mass times gravity sine 25 minus force friction kinetic equals mass times acceleration. Of course, mass times gravity, sine for my x, minus the friction times the mass and the acceleration. My f of y equals to 0. There's nothing accelerating on the y-axis, so I'm going to set it to 0. And normal gravity, normal force minus mass times gravity, cosine 25, cosine, sine for x. So that's how I get that. So I can rearrange this and solve for n like I did right here. And I basically just bring this down. I pretty much just exclude f of x, and I'm showing mass times acceleration equals the mass times gravity sine 25 minus the force friction kinetic energy. So coming down here, I'm showing how I'm substituting the f of x, which is right here. I mean f of k, which is the kinetic force friction, equals mu kn. So sub here, and then it becomes this right here. The n. When I solved for n earlier, I can replace my n here with this problem to get my mass times gravity cosine 25. And basically everything now is just pretty much like a breakdown of everything now. So that shows that minus the mu k mass times gravity cosine 25. I got these underlined to show that basically I'm going to distribute them out That's why I got my mass times in kilogram out here. My mass times gravity out here, sine 25 mu k cosine 25. Right here is because my mass is pretty much cancel out since I'm looking for acceleration. So, again, acceleration equals gravity times sine 25 mu k cosine 25. And my gravity is 9.8, which is my given. My mu k, which is my force friction, which is 0.2. And that was also given in the problem. Kinetic friction, 0.2. So put that in place of the mu k, multiply by cosine 25. Sine 25 equals that. That times that minus that gives me this, and this times the gravity equals this, which of course rounded up equals acceleration. The magnitude of the acceleration being 2.4.